All right, part 3. We are looking at a spherical mirror, radius here at 8, focal point at 4, and this was sitting down here at 16. So how does that appear in the mirror? We're going to do, when I say ray tracing, we're going to do 3 rays, always the same 3. The first ray, remember, all kinds of rays are going to reflect off of this arrow. And I'm going to go from the top of the arrow, and I'm going to ray trace what happens to the horizontal light beam. So there's one light beam that will come off of this and go straight in horizontal to this optical axis. It's going to hit the mirror, and we learned that that will reflect through the focus. So that's one. All right, and if you have another color that you can use, it might help during this training part. If not, kind of keep them apart visually. All right, so now the second one is going to go through the focus first, and it will do the opposite, because any light ray on this concave spherical mirror that comes off of this same point and goes through the focus, this is where you need to draw a straight line, well, guess what? Come back horizontally. I know it's hard to see while I'm spinning it around. I'll show it clearly now. It's going to go through the focus and come back horizontally. And the last ray is going to go exactly through the radius. So, coming off of, and again, when I straighten this up, you'll see it clearly. This one's going to come off the top of the arrow, go through the radius like that. And the rule about that is, we know from geometry, any radius will hit a point on the circle in such a way that it's perpendicular to the tangent. So the reflection will be right back through the same point. So it'll go back at the same, on the same path that it came in. So those are the 3 rays we will always trace. So let's write them down. All right, for ray tracing, you're going to do one ray will go from arrowhead top to the mirror horizontally. So from the arrowhead top to the mirror horizontally, and reflects through the focus. So when I ask you to do a ray tracing, you will always start there, top of the object, straight in, horizontal to the optical axis, and it will reflect through the focus. So that's the first ray you'll trace. The second one is like the second one we did, from arrowhead top and it will go from the arrowhead top through the focus, and reflects horizontally. All right, so here we had one that went in horizontal and reflect through the focus. That was number 1. Number 2 went through the focus first and then reflected horizontally. I did the opposite. And the last one, from the arrowhead top through the radius, reflects back the same it will reflect back on the same path. All right, so the third one went from the arrowhead top through the radius, and it will reflect right back as it came in, right along the same line. So if you've done that correctly, all three will intersect at the same point. So this one, and this one, and they do, right there. All right, that point is important because we started at the arrowhead. That will be the arrowhead, and the tail of it, where it started, will always be on the optical axis. So if I put the tail on the optical axis in the arrowhead where those three rays intersect it, the reflection of those three rays intersect it, I will get this image right there. So again, the tail, where the arrowhead is standing, starting at the tail, will always be on this axis, but the head will be where these three rays that we traced intersect. So notice the image is inverted. It's upside down. And I'm running out of lead. Here, just a second. It's inverted. That means it's upside down. And it is, it's smaller than the original object. The original object was this long and this is shorter. So it is inverted and it is also reduced, is how we can say it. Inverted, reduced, and it is real. So a real image has real light rays that have reflected into a certain spot, as opposed to what we saw earlier on the extrapolated rays from the mirror. None of these were extrapolated. They actually intersected here. So when you're looking into, you have an object situated relative to these focus and radius, the image will look upside down, reduced, and it's a real image. So those are the three words that I am looking for when you're describing your image. Sometimes when I give you a different scenario, it will not be inverted. It will not be reduced. It will be the same or enlarged. It'll be upright instead of inverted. It may be real or it may be virtual. So these are the answers for this problem. Let's see how that changes when we do another one. So I won't write out all the steps, but you have them for your reference. All right, let me take one where I think I'll close this down so I'm not uploading such a long segment. And I will do one more and leave you a couple to do.